Okay, the prolific debugging. Probably among one of the more controversial things in some programming circles, whether you just run the program and roll with it, or you run a debugger like 10 million different times and like toolkits and all that and go from there. But you can do it quite powerfully on a Linux-based system or Unix system. When unexpected behavior is noticed in a program, GNU Linux provides a wide variety of command line tools for diagnosing problems. The use of GDB, the GNU debugger, and related tools like the lesser-known Perl debugger will be familiar to those using IDEs to set breakpoints in their code and to examine state as it runs. Other tools of interest are available, however, to observe in more detail how a program is interacting with the system and using its resources. You can use GDB in a very similar fashion to built-in debuggers in modern IDEs. The Eclipse and Visual Studio, if you're debugging a program that you've just compiled, makes sense to compile it with its debugging symbols added to the binary, which you can do with a GCC call containing the -g. If you're having problems with some code, it also helps to use walt to show any errors you may have otherwise missed that still pass through and allow it to compile. The classic way to use GDB is as the shell for a running program compiled in C or C++ to allow you to inspect this program state as it proceeds towards its crash. We are going to debug it into crashing. But anyway, so you can GDB example. At the GDB prompt, you can type run to start the program, and it may provide you with more detailed information about the causes of errors such as segmentation, seg faults, including the source file and line number at which a problem occurred. If you're able to compile the code with debugging symbols as above and inspect its running state like this, it makes figuring out the cause of a particular bug a lot easier. So you can run it like so, seg fault here, and it tells you the line, which is really cool. After an error terminates the program with a GDB shell, you can type backtrace to see what the call function was, which can include the specific parameters passed that may have something to do with what caused the crash. You can set breakpoints for GDB using the break to halt the program's run if it reaches a matching line number or function call. Thereafter, it's helpful to step through successive lines of code using step. You can repeat this like any GDB command by pressing enter repeatedly to step through lines one at a time. Much like debuggers and emulators, you can go through it one at a time and pause and breakpoint in order to debug maybe a custom ROM that you're building for like a Game Boy game. So this doesn't do it visually so much like many debugger programs does, but it still provides an interface and gives you output on what it's doing. You can even attach GDB to a process that is already running by finding the process ID and passing it to GDB. This can be useful for redirecting streams of output for a task that is taking an unexpectedly long time to run. So pgrep, so finding the process ID in Unix, yeah. So you can like in the wild debug your programs with it. So if I really wanted to, I could debug Fire Dragon currently as I'm using it, but I don't feel like doing that right now. But there are plenty of options for like your processes that you can run to connect in, debug things, figure out what's going on, and go from there. Very, very powerful. Like I don't think Windows has many of the same tools, but I could be wrong. But it also means that you can mess with games on the fly and see what behavior they're doing in order to learn how they work with GDB alone. The much newer Valgrind can be used as a debugging tool in a similar way. There are many different checks and debugging methods this program can run, but one of the most useful is its memcheck tool, which can be used to detect common memory errors like buffer overflow. The GDB and Valgrind tools can be used together for a very thorough survey of a program's run. Zed Shaw's Learn See the Hard Way includes a really good introduction for elementary use of Valgrind with a deliberately broken program. So we can go into here, and does the full book include? No. Yes, the computer hates you, because it does. But anyway, learning C the hard way. It's kind of like the best way to learn things is first the hard way, even though you're going to hate yourself. But so yeah, memory leaks can be, yeah, you don't want memory problems in your program, obviously, because, for example, if you get like a buffer overflow, that means that somebody can mess with memory that they're not supposed to. But anyway, tracing systems and library calls with ltrace. The strace and ltrace tools are designed to allow watching system calls and library calls respectively for running programs and logging them to the screen, or more usefully to files. You can run ltrace and have it run the program you want to monitor in this way for you by simply providing it as a sole parameter. It will then give you a listing of all the system and library calls it makes until it exits. So let's see. You could ltrace ./example and then find your seg fault there. You can also attach it to a process that's already running, much like GDB. Generally, there's quite a bit more than a couple of screenfuls of text generated by this, so it's helpful to use the -o option to specify an output file to log the calls. You can then view this trace in a text editor like Vim or pipe it out to less. I found ltrace very useful for debugging problems where I suspect improper linking may be at fault, or the absence of some needed resource in a chroot environment, since among its output, it shows you its search for libraries at dynamic linking time and opening configuration files in etc, and the use of devices like dev random or dev 0. So you can know what resources it's trying to pull in by tracing it back. So LSOF, if you want to view what devices, files, or streams a running process has open, you can do that with LSOF. For example, the first few lines of Apache 2 process running on my home server are right there. Interestingly, another way to list open files for a process is to check the corresponding entry for the process in the dynamic proc directory. So proc is very powerful in that you can find all kinds of things in there if you sift through like proc and dev. There's a lot of stuff you can access there and mess around with. This can be very useful in confusing situations with file locks or identifying whether a process is holding open files that it needn't hold. So it kind of like when you're talking about the resources that there are, dev and proc have a lot of resources. So for example, I can go and I can see that I've got, where is it? Oh wait, no, it's going to be up here. So like I've got my NVMe drives in here, and dev NVMe 0 and dev NVMe 1. And then it lists the partitions as separate devices on top of that as well. Now I've also got like different NVIDIA drivers and so on devices, HID draw, you've got our VFIO, and so on. If I was using LVM for managing volumes on my drives and combining volumes, then I would see a directory for my LVM stuff in devices as disks as well. And then I could go through the directories in there and go through all the different partitions and stuff, or different volumes that are separated down based on what they are on top of that. Proc has more of the processing stuff, so I could go through current working directories and so on. But yeah. And then run has a couple different things, so like LVM in here, run it stuff. Where is it? Mount, no. Or was it? I don't remember for some reason. But I'm pretty sure it's in here. Run, user, no. But here's my pipe stuff for all that stuff. So I can, all the files in here are in essence sockets and things like that. And then in some cases drives that are mounted in here, if I can find where that is. And I'm trying to remember. And I can't for some reason. And I thought it was under media, but it wasn't. Those are network devices. That's the other stuff. Samba screens, SDDM, sudo, SV, SVNC, systemd because that's there. It mounts stuff in run. I remember that much. So I think it was run media, and that might be a directory created on the fly that does that. But yeah, that it's where a lot of things live. So viewing memory allocation with PMAP as a final debugging tip, you can view the memory allocations to a particular process with PMAP. This will show you what libraries a running process is using, including those in shared memory. The total given at the bottom is a little misleading, as for loaded shared libraries, the running process is not necessarily the only one using the memory. Determining actual memory usage for a given process is a little more in-depth than it might seem with shared libraries added to the picture. So it may use less memory, but it's just including all the libraries it's referencing for its total. But yeah, cool debugging tools tells you a lot of information. And in some cases, I think more information than some of the other debugging tools give you. So like, I have that right there with me, which is really nice. If I were to go into and open this, I can plug in my external drive and then pull that up. If I can get the plug in the right direction. Okay. No, don't type for me. Thank you. So I always have to add dbus run session to my thing in order to get dbus to run properly when I'm running up river. But anyway, give it a second to mount. And there we go. So I can go over here. I can go to run. And I see media is a directory created on the fly. It shows the user that's got it, and then the directory there. And then it has all these different things in it. Interesting. But anyway, so I could flip through a lot of stuff in here and be fine. But this is really cool because it means every file resource is a file, and if I go back to dev, I should see that I have an SDA and an SDA1 now that is in my dev that wasn't there before, because I've connected a new device to it, and I could interact with file system command, make file systems on SDA1 as well, because it's an object that accepts those kinds of commands. If you enjoyed the video, then like, comment, subscribe, feed the algorithm, boost the video up, share this video with your friends. If you found it informative or you just want to chat, I've got plenty of places in the description, Discord, Guilded, and what have you. Check those out, and I will see you guys in the next one.